Hello, my peeps, and welcome to another Power Packed Phillips podcast. I think some of you will be getting check marks. Nice job. No, you're not number 11. That was Mr. McGrath. But I do believe, nice job, Math Munchers, place in number 14. Nice job, Fraction Freeloaders, place in number 19. And I'm thinking, no check mark for you, Supercalifractions. And I do believe that we have one more set of scores to go through. This would be the week 14 scores. Nice job, Supercalifractions, placed in number 15. And also shout out kudos to Math Munchers at 17 and Fraction Freeloaders at 18. Some MSAs for your viewing pleasure. And before we get started, oh wait, it's LeBron crying. And all I have to say was how sweet it was to drink that Haterade over spring break. Today's podcast is going to be on lesson 9.7, factoring special products.
What?
Remember in our previous podcast we were talking about factoring a trinomial, tricycle, 3 wheels, trinomial, 1, 2, 3 terms.
Uh-oh.
In today's podcast, we're going to talk about factoring a binomial, like a bicycle. Bicycle, 2 wheels, binomial, 2 terms.
Whatever.
All right, please write down the binomial y squared minus 16 on your paper. And we are going to factor this binomial, 2 terms. Well, the first thing we're going to do is say, how can we get y squared? Well, that's pretty easy. That's going to be y times y. So you're going to put your 2 sets of parentheses like we've always been doing. Put a y at the front of the first parenthesis and a y at the front of the second parenthesis. Now let's take a look at the number 16. We say 16 is one of those special numbers. It's what we call a perfect square.
Oh yeah.
And the reason why we say 16 is a perfect square is when you multiply a number by itself, you get what we call a perfect square. So notice right here on the screen, all these numbers here that are colored in yellow that are going diagonal are what we call perfect squares. 1 times 1 gives you 1. 1 is a perfect square. 2 times 2 gives you 4. 4 is a perfect square. 3 times 3 gives you 9. 9 is a perfect square. 4 times 4 gives you 16. 16 is a perfect square. So you need to remember, when you multiply a number by itself, that's going to give you a perfect square. So we said 16 is a perfect square. We can multiply 4 by 4 to give us 16. So over here, I'm going to put in a 4 and a 4. 4 times 4 gives us 16. But notice that I want negative 16. So to make negative 16, I would do positive 4 times a negative 4. So that's going to be a positive 4, and that's going to be a negative 4. That would be your solution. If you FOIL it, go ahead and FOIL it, you should get y squared minus 16. Let's practice another one. if you write down x squared minus 49y squared.
Cool.
First thing we're going to do is, how can we make x squared? Well, that would simply be x times x. Again, I can multiply two numbers by themselves to get 49. So we say 49 is a perfect square. We can multiply 7 by itself. 7 times 7 gives us 49. So we say 49 is a perfect square. So I'm going to put a 7 here, and I'm going to put a 7 here. But notice, again, just like on the last problem, I want negative 49. So to get negative 49, I could do positive 7 times a negative 7, and that would give me negative 49. So one sign is going to be positive, the other sign is going to be negative. Now, how do we make y squared? Well, that's pretty easy. To make y squared, you would simply do y times y. Again, if you were to FOIL it out, and you can pause this video and FOIL it out now, you should see that it will check. Alrighty, let's take a brain break here for a second, and hopefully you've been paying attention during this podcast, so when you hit an obstacle on the EOC, you can be as creative as this person. So when the EOC throws an obstacle at you, you be creative like that lady and find a way through it. Alrighty guys, this will be our last problem. If you write down the polynomial or binomial 8 minus 18n squared, we're asked to factor it. First thing I notice, 8 and 18 are even numbers. So let's rewrite 8 and 18 and see if they have any number, or see if they have any variable or letters, in common. So I know they're even numbers, so I know that 2 goes into both of them. So I'm going to rewrite 8 as 2 times 4. Don't forget to bring down your subtraction or negative sign. I can make 18 by using 2 again. 18 can be broken down into 2 times 9. So I have 2 times 4 minus 2 times 9. Now, how can we make n to the second power? That would be n times n. I'm looking to see if they have anything in common. I see that they both share a 2. They both share a 2. So, we are going to write down that they share a 2. That's right here in my triangle. Then I'm going to put my parentheses, and don't forget, I love leftovers. Had a lot of good leftovers over spring break. So in my parentheses, I'm going to write down what I have left over. I have left over a 4, a subtraction or negative sign, a 9, and 2 n's. So this is where I'm at so far. Remember, put your leftovers inside the parentheses. Now, we can rewrite n times n as n squared. So over here, I'm going to rewrite n times n as n squared. Now, I'm going to cover up the 2 that they share have in common, and I'm going to try to factor some things here. So let's factor the 4 here. I'm thinking if I come down to my chart that 4 is one of those perfect squares. Why? Because I can multiply a number by itself to make 4. 2 times 2 gives me 4. So since this is a perfect square, I don't want to use 1 times 4. I'm going to use 2 times 2. A number multiplied by itself gives you a perfect square. Now, I'm going to try to factor the 9. Well, I know that I can multiply a number by itself. 3 times 3 gives me 9. So don't use 1 times 9. Anytime you can multiply the number by itself, perfect square would be an easier route to go. So I can put a 3 here and a 3 here. Now remember, I want a negative 9. So to get negative 9, I'm going to do positive 3 times negative 3. So one of my signs is going to have to be positive, one's going to have to be a negative. So I'll put a positive here, and I'll put a negative here. Almost done. How can I make n squared? Well, that's easy. N times n. N times n. The last thing I need to do is I need to bring down the 2 that was right here and place it in front of my parentheses. So last thing you do, take what they share, they have in common, and put it in front of the parentheses. This would be my solution to factoring this binomial that we started with up here. This is what we started with. This is what we factored it out to be. All right, thanks for watching, guys. I'm gonna jet out of here.